So 2 seconds, I'm at 3 meters. 3 seconds, let's see. So 0, 1, 2, 3 seconds, I'm at 2 meters. 4 seconds, I'm still at 2 meters. 5 seconds, I'm still at 2 meters. Okay, so on and so forth. So let's, Power School, pick on somebody to come on up here and chat with us about the graph here. Ooh, we didn't do this yet. All right, Sanchez is at an appointment. Bump, bump, bump. All right, Power School would like to hear from, hey, Riley Goodfellow. Come on up here with your buddy, and you can do either the graph or the written description of this motion. Whichever you do.
I'll do the graph.
What's up?
I was gone yesterday.
Uh-oh, you need a sheet? Yeah, where's that? Excuse me, ladies. Anybody else?
Children. Okay, how do I do this? Oh, oopsies. How do I do the line draw thing?
What? Oh, it's not working?
Oh, I like typing it.
Oh, you want to type or you want to use the pen, bro?
Oh.
Here, you type. I'll make the graph.
Okay. So 0,
type.
5 meters. Right there. It goes down to 4 meters, right? And 3. Then 3 again.
Okay, cool. Yeah, I'll
Wait.
Here.
Am I doing that right?
Is it working?
I didn't know you were done yet.
Oh, you got that wrong.
Oh, race. Oh, hold it down, remember? One more. Yeah, 2.
Yeah.
And then it goes down, right?
Oh, I know. I don't know what I'm telling you. I think they go back this year anyways. Because it's been what? I thought it was supposed to go into Disney.
Goes up 2, right? Wait to here. To here?
Yeah.
I'll make these better.
No, just let me go.
It's not in cold water. I know, but it's still alive. Smart one.
Kate's Hair Bear. Nobody calls you Hair Bear?
Kate, did you get down the back of your basketball warm-up?
This squiggly this line, I think I've ever seen that.
What are you doing?
I have to make the lines.
Can you just let me
A
go?
bat.
All right.
How do I type?
Okay. Questions or concerns on that graph at all? Okay, the line is. All right. So Paradex, open up. You got a question or concern on that graph? Go to oil.
Really? Like over my car, like for 40 minutes.
Stumpy.
Peaches, you can do it, All you gotta
This
do
food
is
is just right in my face.
You got a brother named
You know
Tully.
Riley's boyfriend?
You got a brother named Travis.
So, yeah. So, every time I walk out of the house, I like see him. And one time he's just like starting to drink my chick. He's like, oh, yeah.
Who?
You're so nice though.
I know, I love him.
Riley and Morgan's boyfriend.
Are they still dating?
Apparently.
Apparently she like loves Iowa and is doing really well there.
Wait, what'd you say?
Apparently she like loves Iowa and is doing really well.
Good for her.
Good for her then.
Who's she hang out with the same friends with?
Why wouldn't she?
Go.
Well, I can think of some
struggled in
reasons. But I feel like, you know how people have like presentations in high school?
Yeah.
And like, then when you get to college,
No
like,
namer.
like, you don't
No
really
namer
feel like a
pluggy.
kid in high school. So like, you kind of go into it thinking everyone's gonna be cool. Like,
You know how I should have known it was yours? 6.5.
I'm excited.
That's good to hear.
I'm also like really fucking scared that
Do you like work at the mall?
that's a conversation for another
oh,
time.
what did you just say
I'm really scared that you'll like make the wrong decisions.
about college? I thought you were pretty young.
I feel like you should have like along with.
I am, that's the problem.
Yeah, you should.
Like I feel like I'm like too set, you know?
You're applying to other schools besides that school.
I'm trying to drink.
Burbage. Yeah, slap your name on that.
This, are you kidding?
How do you?
I don't understand. Number 3, appropriate units on slopes.
What's
and
number 2? Tell me what number 2 is. What's number 2?
Equation written with variable names. And choices.
I did. I'll be back there.
Hey, and again with these lads, if you've got a light stand, hang on to it, because chances are I can make some kind of powerful error. It's a lot easier to fix. You can
This
just
is
say, hey,
position.
you donkey, I've got this stand, where's my 10 points? Another no-namer?
Oh,
Yes, that's what.
position.
And please.
Wait, what's the unit?
Wait, which one's position? And which one's
Position. This is meter slash second.
No, I don't know.
I think it is right because he didn't put that.
Medicare. No-namer.
Okay, I can turn this in. Can you go turn this in? When you're done with yours.
No-namer with a blue pen and a red pen.
Probably less.
When you're resubmitting, please resubmit it to the red basket. All right, so the text box. Whoa, what the? Home.
Tomorrow is my last day for
Ooh. All right, so the written description motion moves in a negative direction, then stops at 2 meters, then keeps going in a negative direction and stops again, then starts moving in a positive direction. So again, over on the Pear Deck, any questions or concerns, suggestions for revision?
You know how I was showing that you see that little bit of this, yeah? So I was
What are your friends saying on these?
I was gonna like try to find someone that I knew and like introduce them, you know.
Written description, you gotta beat with it.
And Tasia comes walking down the stairs and this girl goes, Tasia? And Tasia goes, and they like jump on top of each other and are hugging. I'm so scared for like 2 minutes. And I'm like, Tasia, do you have lunch right now? She's like, yeah. And I was like, you want to show her how to do the whole lunch thing? And she's like, of course. They were like screaming, and I was just standing there like, it's so weird.
None was nice,
Yes,
none.
because I was walking her lunch, and then all of a sudden she was like,
Feed the
Tasia? And Tasia was like, oh my god.
feed.
Literally hugged her. They were both like screaming. They were like,
Epic.
this is the student I was showing her.
All right, feed for speed. Hey, so again, the goal, as it were, is that you could give this description to somebody and they would draw a graph at least with the correct shape. And so it's a little bit tough to tell because whoever drew this was clearly nervous based on how shaky all the lines are. But are these all equally as fast, or is there one part of this that's faster than another part? Run that by your neighbor really quick. I mean, there are clearly spots where it's stopped. Kiana, what do you got? Hey, shh, 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 shh. What'd you say, boss? It's about something else. Perfect. All right. Anybody got anything about where is this thing moving fastest? Or when is this thing moving fastest? You can type it in back there. I'll be able to read it. Boop. So I see back here when it's going in the positive direction, it moves faster after 9 seconds. The last 2 seconds are faster. Okay. Hey, can I give you a heads up? Help you not lose points on the quiz on Friday? I know what this person means. I see it right down there at the bottom. It says when it's going up. Okay, keep in mind this thing is just moving like left to right. Never is moving up or down. I think they're describing the graph, and the graph is going up here. And I'll try to help you with this as we go through the week. Be aware of when you're describing the graph and when you're describing the motion. This thing didn't physically move vertically upward, but I would agree that when the graph is going up, that's when it's moving fastest. And how do we know this? Like people are answering with the last part of the motion. Let me throw another question at you. And sorry if you already had this in there, somebody. How do you know? Okay, we're saying the last part of the motion is the fastest. What are the indications? That's the important thing to me. How do you know that's when it's fastest? The end. Oh. Fantastic. Okay, lots of great answers over there on that. So I'm seeing things like greater slope or steeper line when we're looking at the graph. That's what I was just talking about, but that's an okay justification here. Like, how do you know it's going faster? The graph is steeper. Okay. It's going farther in 1 second than before when the dots are more spaced out now. You can see the slope. It's more steep. It's traveling 2 meters per second as opposed to just 1 meter for every second. In 1 second, the position goes 2 meters. You cover more meters in 1 second. So we see that when we look at the motion map, right? Down here, the spacing is greater than it was up here. When we talked about the dots the other day with the buggy lab, that's the idea. It's dots are farther apart. It's going greater distance in that time interval. Okay. Let's go ahead and flip it onto the back. I don't know that I want to necessarily make people come up here. We can just kind of run this off the Pear Deck, I think. So what are the important questions? Hang loose with me here. So we've got position versus time graphs for cyclist A and cyclist B. Okay. And those are straight lines. I think everybody's hopefully perceiving it that way, but like this is all one thing, and then this is that's pretty much invisible what I just did there, but hey, I'm trying. I'm most interested in this question. B. So at 7 seconds, who's ahead and how do you know? Okay, so fire that in there for me. I'm just going to ask you a couple of questions on this page, and maybe we'll get on with the show. Here's the part I'm particularly interested in, your justification, right? How do you know? Argument with evidence. All right, here's a couple of things that I'm seeing when I look in. So A has a higher Y value. A because the line is above the other one. Okay. So if we're looking at where 7 seconds would be, it'd probably be somewhere around here. And if you look at the graphs at that time, oh man, that would be the position value for, right? X and Y are just terrible things to be using here. Right? A would be A's, the line for A is above B, or it's got a greater position value on the axis there. So clearly A is ahead at that point, okay? Something along these lines. How about this question? C, let me freshen up the question. Who's ahead? Or I'm sorry, not that. That's not the question. Question is, which cyclist is traveling faster at 3 seconds? But again, most important part, how do you know? Who is faster at 3 seconds, and how do you know? So again, which cyclist is traveling faster at 3 seconds? In addition to A or B, I'd like to know your reasoning, so please try to include that. All right, I'm going to lock this down just so people stop editing for a sec. I'm going to throw a couple answers up here for you. Can I shrink that? Does that zoom? That doesn't ping. Control minus. There we go. All right, so I've got cyclist B is ahead because of 3 seconds. Cyclist B was at a higher position than A. Thus, meaning up to the 5 second point, they were traveling much faster due to their higher position. We've got cyclist A is going faster because the slope is steeper. A is traveling faster because A has a steeper slope. And then I have down here B because it is above line A. So I want you to, those are like, there's kind of, I think these two go together. I think these two go together. You have a conversation with your neighbor about that real quick. Okay, where are you at, neighbor? A or B? I would mention too, this is kind of like your notes. Okay, this is kind of like where we try to make sense of stuff. So hopefully you got the sheet out. You're kind of jotting things down as we go. You might even jot down kind of the contrast here, like, oh, okay, some people think that this, some people think that this. That might just help you out a little bit too. Does this throw out a multiple choice at you? All right, there you go. Vote for A or B. All right, that's pretty unanimous. 22 of 27 people voting, and they're all voting for A there. So we can go with that. It's not in the lead, but it's faster, right? Can you imagine what that looks like? So what does it look like on the road if you're driving a car and you're going faster than the car in front of you? What's happening? You're starting to what? You get closer, okay? And then that kind of leads into this next series of questions. D, are their velocities equal at any time? Let's just go yes, no there, okay? Are their velocities equal at any time? Try to join us. I'm still waiting on 10 of you to commit to an answer here of, are their velocities equal at any time? Yes or no? All right. It's not unanimous, but it's not 50-50 either. So could you take a moment and chat with your neighbor? See if you can sway them to your line of thinking. All right. Right now it's 20-5, one of those ways. So it's still not unanimous. But I think this might bring some clarity for us. Let's talk about what's going on at E. So I'm going to throw a new question at you. What up with E? E is the question. What's happening at the intersection of lines A and B? So they're talking about right here. So in other words, at 5 seconds, what's happening? Wow. Okay. This looks pretty uniform. So let's take a gander at what our friends are saying on the internet. Cyclist A is passing B cyclist. A is passing B. Meeting at the same position where A is going to cross it, go faster. Two cyclists to the same location. A is passing B. A caught up to B. A is about to pass B. Same. Oh, they intercepted, meaning that they were at the same speed during the 5 seconds. Okay. A catches up with cyclist B. They intersect. A arrives same distance where B is at 5 seconds. Same distance at the same time. Same position. Cyclist same distance. Same position. So I'm gonna throw this at you, right? Because like same distance, same time. Is that not the same speed? Run that by your neighbor there. What's your rationale for or against that? Oh man, that's no fun. Oh, you're just answering it with your neighbor. So I would say this. Yeah, they're at the same position at that time, but I would not agree that they had the same speed during that first 5 seconds. I think red has a greater speed. And why I think that is red goes farther in that 5 seconds. Red starts at 0 and ends up at this spot. But this kind of ties into that initial question. Blue doesn't go as far as red does in that time. I kind of want to do a little physics theater here. So talk to your partner. We'll throw it into Power School. I'm going to ask you to come up here and walk this graph for us. One of you will be A, one of you will be B. Okay. So talk to your neighbor. What are we going to do? Where's the origin? Let's say we'll call the marker hat. This is 0. Can I make it 0 out of this one? Here we go. 0. Okay. You and your buddy are going to have to come up here and walk this. We're not going to be like really specific about times, but how would this look? I don't want to catch anybody out, so I'm giving you time to talk right now. My Power School pick on you. It's going to pick Rachel, but it could pick any of you, so just think about it. Oh, not Rachel.
Oh, Grace.
Grace. Grace and friends.
My friend. Wait, is it me or?
It's Abdul.
Oh.
That's your buddy, your partner. All right. Have a quick chat about what you're going to do. Wow, why is that not pinch moving? Okay, and like sort of the thing of interest on here is like 5 seconds. So like tell us when 5 seconds is happening, okay? And let me stage this here. Is there oh yeah, there we go. All right, cool. So you're gonna be able to give this a thumbs up, thumbs down here, okay? So you tell us ding when you're ready to start, and then shout out when it's 5 seconds.
Ding.
5 seconds.
All right, so thumbs up or thumbs down on the thing there. America's gonna vote for you here. I call this walking with the stars. Don't be trolls. I know who's doing what, so. All right, on this episode of America's Got Talent, let's see where we're at here. Boop. Oh man, look at that. The crowd loves you. Okay. So yeah, there we go. That's the key thing with this graph is B starts out ahead, but B's always going slower. We see that by the graph for A being steeper. Okay, this is steeper, Monte Scarpato. B, that's flatter. Okay, so it's always slower. This is the point where they're at the same place at the same time. They can high five, but again, it's just like out on the road. Okay, you're going faster than the car ahead of you. Eventually, you're going to catch up. Doesn't mean you're going the same speed. You're still going faster than them. That's how you get by them. All right. This last page, this is for you. Okay? If you want some extra practice with these ideas, getting ready for Friday, work through this on your own time. You got questions on it? Email me. I'm available 3rd hour. I'm available 7th hour. I'm available AFT. If you got questions or concerns, hit me up. But this would be good practice getting ready for stuff on the thing. Where you at? Velocity we've defined in here is the slope on a position versus time graph. So it's asking you to compare the slopes of the position versus time graphs. All right. I want to talk about 2 key phrases here. And those are displacement and distance. Okay? Displacement is a fancy word that means change in position. Distance is a little bit less fancy. It's like the odometer reading in your car. Or I think of it kind of in a more modern era as like a Fitbit or a fitness tracker, okay? A pedometer. Let's just use simple words. It's a step counter. Okay, so what do I mean by that? So, again, if this thing is the origin, if this is 0 on our number line, right now I'm at 2,806 steps. Okay, 2,806 steps. I'm going to go for a little walk here. Follow me. So this is 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now I'm at, we'll pretend it says 2,816 steps. That's a 4-star review that's about to happen for this thing. That's because I walked 10 steps this way, right? So my tracker now says 2,816. If I walk back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, what should my step counter now say? Run that by your neighbor real quick. All right, so again, so I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do this. Why would I need you? And then 1, 2, 3, 4, 5, 6, 8, 9, 10. So I start off at 2,806. I walk 10 steps that way. The thing should read 2,816. Doesn't because refurbished. But it should read that down there. Okay? When I walk back to here, what does it say? Does it go back to 2,806? Yeah, it's going to be 26 because I walked 10 more steps, right? It's just always adding up the steps. That's like the distance. That's how distance works, total distance. But in terms of my position, I start off right here. I end up right back here. How much has my position changed? Nothing. I'm in the same position I was before. Okay? So my displacement, my change of position would be 0. Okay? So like you, generally speaking, on a given day, you begin your day and end your day in the same location, chances are. Okay? So your total change of position for the day, not taking into account all the thousands of steps you walk, would be 0 because you're right back where you started. Okay, but in terms of distance, your step counter going to read like 10,000 steps. Okay, so we're going to apply that to this situation and rank these graphs in terms of their displacement. Okay, so remember displacement, we're talking about the change in position, final position minus the initial position. And to make things slightly more complicated, it wants you to consider positive and negative. It wants these ranked from most positive to most negative. If we haven't done a ranking yet, it should look like A greater than D equal to B greater than C, something along those lines. So go ahead and check that one out and then throw your ranking in here into Le Chromebook. Rank these on displacement. Change in position. Who had the most positive change in position to who had the most negative change in position? Again, this says most positive to most negative, so be mindful of that. So that's saying that 0 is greater than -2 and -2 is greater than -4, okay? Once you've got your ranking, and again, please use greater signs or equal signs. It should look something like this. Just go ahead and type that into Le Chromebook. Smart things to do, like write down your ranking on the paper, and then if it changes after we talk about it, that's an important thing to track. Track changes.
Wait, what were you saying?
GG, you got 2 Fs in your rankings.
Oops, that was me.
I don't even think it's like, I don't even think my
Is that right though?
I just kind of wrote. But I'll just say whatever. I started at 10
All right, so here's 4 different rankings. They're not all complete. Some folks think A and B are equal. Some folks think B and C are equal. Some folks think C is the most positive. So again, phrasing, most positive. Some people think A is the most positive. Some think D is the most positive. Some think F is the most positive. We're talking about less talking, my friends. We're talking about change in position. So that means I need to look at where does it start. In this case, P1 is equal to 0. And at the end, its position is 10 meters. So I'm going to call that P2 equals 10 meters. Okay. So when you're thinking about change, initial plus change equals final. We'll talk about that some more tomorrow. Bye-bye.